There are four types of resolution: temporal resolution, spatial resolution, spectral resolution, and radiometric resolution. Now we will discuss about the spectral resolution. Let's have a look about the shape and size and nature of the spectral band. From EMR we can get this spectral band, and this part blue, green and red, better to say RGB, is the visible band, and this in right hand side of the visible band, that is the infrared band, most widely used in remote sensing method. We are all familiar that within the artificial satellite it may be polar orbit, orbital or the geostationary, always contain contain the bands or several bands, or rather better to say several spectral band. And most of the cases this band include the visible band RGB and the infrared. Okay, and EMR reflected by the Earth's surface, or the EMR reflected by the object which have temperature above the 0 Kelvin, rather the above the temperature of absolute 0, and they reflected EMR, and that's reflected EMR recorded by the sensor. Rather, this reflected EMR recorded by the spectral band or the band of the sensor. Okay, so come to the point. What is the spectral resolution? Spectral resolution is the quality of a sensor, quality of a artificial satellite, quality of an imagery that recorded by the several bands of a sensor within the specific wavelength. Okay, so spectral resolution is nothing but a quality that recorded by the bands, that those bands are the spectral bands of the sensor with the specific wavelength, and that sensor can record within the electromagnetic spectrum. So come to this picture. Okay, there are three bands: bands 1, bands 2 and band 3. Those are the visible band. This is blue band, this is green band, and this is red band. This is the visible band, and this is the band 4 is the infrared band. Okay, suppose from a tiniest part of the earth subject, tiniest object of the earth's surface reflected EMR, and this reflected EMR sensed by the recorded by the sensor. Rather, this reflected EMR are sensed by the various band of the sensor. The object is fixed, geographical area is fixed, but the reflected of the various band, the reflected recorded by the various band is not uniform. Okay, suppose a small stony area reflected EMR, that EMR recorded to the sensor, to the recorded by the various band of the sensor. Blue band recorded that kind of information, green band recorded that kind of information, and red band recorded that kind of information, and same wavelength, same reflected recorded by the infrared band is that amount. So within this reflected of the reflectance energy of a same object recorded by the sensor, recorded by the various bands of the sensors, it may be recorded by the single band, may be recorded by the multi-band. Okay, may be recorded by the visible as well as the infrared band, but uh, the numerical value of the reflected of the wavelength of the various band is not uniform. So we can get gets 4 or 5 images of that particular area, but we can get a image of blue band, we can get a image of green band, we can get a image of red band and infrared band within the same area. This is the basic theme of spectral resolution. Suppose the object of an Earth's surface which have a temperature more than the absolute 0 or 0 Kelvin start to reflect EMR. That EMR reach to the sensor or reach to the various bands of the sensor. Here, the blue stands for blue bands, red stands for red bands, green stands for green band, and that's reflected EMR recorded by the various band. The wavelength and numerical values of that reflected EMR is not uniform through all bands. Blue band recorded that band separately, red bands recorded that EMR, that reflected EMR separately, and green band recorded the reflected EMR separately. And those three specific bands recorded the reflected of a same object and same time, and due to the differences in the spectral band, the spectral signature of that particular object, that is the wavelength, recorded separately, separate bands. Okay, come to this slide. Okay, this is the visible band. It consists of red, green and blue. We are all familiar that these three colors are the basic color. We can create lots of colors from this red and green, blue. If we merge the three band, red, green and blue band, merge and consider as a single band, and if someone gets a satellite imagery from that band and that band is most white band, then we can get the black and white imagery. Okay, from visible band, if we consider the red, blue and green band as a merged band, and if we consider it as a single band, from that single band we can use, if you use single band, we can get the black and white imagery. That black and white imagery is called panchromatic image, and the range of black and white scale is called grayscale. Okay, and if someone split that visible band into the blue, that is range from, and green and red, and take imagery from these three separate band, those are the visible band. In spite of that, those are split into the three parts, then someone can get the blue imagery from a blue band, imagery from a green band and imagery from a red band. That is the imagery of a multispectral band. Here we considered or used the visible band to split it and used as a multispectral band, and this multispectral band is more effective than the panchromatic band or the panchromatic image, or rather black and white image. So in remote sensing, multispectral band is more effective. Very simply, EMR reflected by the earth object, it's recorded by the sensor or the various band of the sensor. Reflected from reflectance of an object is not uniformly recorded in the various band. There is a variation in wavelength, that is called the spectral signature. From the different spectral signature, we can identify the object of the Earth's surface very easily. Now come to the point of multispectral band. I have already discussed it consists of several bands. It may be split the visible band into the three parts, red, green and blue, and it's also split the infrared band as a near infrared, mid infrared and thermal infrared, and takes information or gets information of a particular area or particular object within the several band with the several spectral signature. Okay, so multispectral image is more effective and more useful in remote sensing method. But here I would like to mention that spatial resolution, that is the area coverage, may be same in the case of panchromatic image, that is the single band image, and maybe same, may be equal to the multispectral image, that is it's used more than 2 or 3 bands. Are basically the imagery or the information recorded by the single band, that is the visible band. It's a very wide band. It's the image, normally you can get black and white image. That image is called panchromatic image, and that image display the band. This is known as a grayscale image. Okay, and This is a picture of a spectral band, and this is the visible range. We are all familiar with that RGB, and this is the infrared. Multispectral remote sensing, multispectral resolution normally used, visible band, and it used as a splitted band, red, green and blue, and also the infrared band also splitted into the near infrared, mid infrared and thermal infrared. And radar can also use more band than the multispectral band. Radar can use this wide range of band. Okay, so be clear. From satellite imagery, we can get a very clear object. We can have very clear object if the imagery recorded by the more than one, two, three, rather multispectral bands. Okay, multispectral band is more effective in remote sensing. Okay, this is the picture of a hyperspectral or multispectral bands. Here there are several bands and EM are reflected by the Earth's surfaces and reach to the sensor and reach to the various spectral band, and its various band records the EMR reflected in EMR in uneven way. Okay, come to this point. Suppose a earth object which consists the temperature more than absolute zero and can reflect EMR. That is reflected EMR recorded by the blue band, green band, red band and infrared band. Okay, and from that separate recording we can get separate image. From blue band we can get a blue band image. From the green band we can get a green band image. From the red band we can get a red band image. From the infrared band we can get a infrared image of a same area of a same time. Within the merging system of all this image, we can get more clear, more informative information about the Earth's surface. Okay, so multispectral band is more effective than the single band. Okay, this is a picture of a multispectral band. Okay, we can get more information and more vivid, clear picture about that area if you used multispectral band. This is also the picture of multispectral band. It is more informative. Fourth one is the radiometric resolution. Radiometric resolution is the sensitivity of a sensor. What is sensitivity? It's the ability to measure. It's the ability to make distinction within the same spectral band of difference in electromagnetic energy reflected by the Earth's surfaces. Okay, try to think very simply. EMR reflected by the Earth object, it's recorded by the various band. It may be recorded in blue band, may be recorded in the green band or in infrared band. Within the same band, it may be blue or green or red. Within the same band, there is a variation in brightness. There is a variation in the electromagnetic energy. There is a variation in brightness or variation of electromagnetic energy. Within the same band, there is a variation of electromagnetic energy that is called the sensitivity. That type of resolution that is recorded by the sensor, that kind of information is called radiometric resolution. Okay, we learned everything from the nature. Basically 24 hours is our solar day. We can divide the solar day into the two equal parts within 12 hours and 12 hours. The first half of the 12 hours is the day and second half of the 12 hours is the night. Maybe vice versa. This is the blackest part, white and blackest part and white part. That is nothing but a day and night. We can divide the 24 hours on the basis of received EMR on the Earth's surface. We can split it into the day and night. Within the received EMR and intensity of light and within the intensity of brightness, we can divide the 24 hours into the four part. We can slot it within the 6 hours differences. And similar way, we can divide the 24 hours within the 1 hour interval. Within even we can divide into the 30 minutes interval, and we can segment it 24 hours into the several halves. What is the basic reason behind that fact when we are using the clock and divide the time? That is nothing but the intensity of sunlight, rather intensity of received EMR, and we can slot it into the various parts. It may be day, night, maybe time, maybe hours, minutes, seconds, all these things. This is the basic reason behind the radiometric resolution. Day-night is a very good example of grayscale. Day-night is a very good example of beat system. Okay, come to the next slide. We learn everything from the nature. 24 hours are the solar days. 24 hours is the solar day. We can divide it into the two equal half. That is the day and night. What is the reason behind that kind of division? On the to receive sunshine or receive EMR, on the basis of receive EMR, we can divide the darker part and lighter part. And darker part is the night and lighter part is the day. If someone want to divide the 24 hours, that is the one solar day, and he or she can divide into the four equal part, then the division or interval will be within the with follow the interval of 6 hours. Okay, and if someone want to divide that one solar day or 24 hours, he or she can divide into the 16 parts, 32 parts, 64 parts, so on. And basically our clock system, that seconds, minutes and hour, is nothing but the division of a solar day. And what is the reason behind that kind of division? The reason behind that kind of division is on the basis of received EMR or received insolation. Okay, this is the basic thing or basic principle followed in radiometric resolution. Okay, in imagery system or in remote sensing, data are represented by the positive number. There is no use of any negative value or any negative number. All are positive. Okay, it starts from the zero. Okay, and it is goes on, it's move on, or it is selected to power of 2. Okay, 2 to the power 2, so on. No, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, so on up to 2 to the power 12. This is called nothing but a bit system. Okay, what is bit system? It's follow the binary format. What is binary format? Basically we are talking about the 24 hours of a solar day. It's basically divided into the two part, day and night. Okay, human being, basically now we are talking about lots of discussion is going on about the third gender. Basically human being divided into the two part, male and female. Okay, this is the best principle of binary system. Okay, the range corresponds to the number of bit used for the coding number in binary format. That principle is followed for the radiometric principle. Each bit record an exponent of power, that is day and night, that is division of 2 power 1, that is day and night, it's divided into the 24 hours is divided into the 4 parts, that is 2 to the power 2, so on. This is the basic principle behind the radiometric resolution. The maximum number of brightness depends on the number of bits. Okay, so radiometric resolution increase towards the right hand side, follows that kinds of arrow, because more bits are responsible for more brightness. We are all familiar about the paint. When we are doing paint in Microsoft Office, then 0 to maximum range of the variation of color, that is black and white. That is the variation ranges from 8 bit 0 to 256. Okay, so brightness, the variation of day and night, variation of extreme black to extreme sunshine is defined by the beat system. Okay, so radiometric resolution is the sensitivity, is the measure of sensitivity within the specific band, within the particular band, on the basis of recorded electromagnetic energy of from the reflected from the object. Okay, this is the basic principle of radiometric resolution. More radiometric resolution provides more clear picture. The finer radiometric resolution of a sensor means it detecting, it identifying the small differences within the reflected energy within the same band. Okay, this is the panchromatic image, but radiometric resolution is 8 bit, so we can easily identify the ranges. Okay, ranges of mountain. Okay, now come to the point of grayscale. What is grayscale? Okay, we learn everything from nature. Day and night is a very good example of grayscale. Okay, grayscale depends on the intensity of light, rather intensity of EMR, intensity of brightness. It depends on the brightness. Grayscale is the range of the shades. Okay, shades in between the black and white. That is the grayscale. Normally, grayscale, we can get grayscale from the single band image. Single band image. It is also known as monochrome image. Okay, black and white image, or panchromatic image, or pan image, or monochrome image. And grayscale or black and white image also called as a binary image. Black and white, that wise it is called as a binary image. Radiometric resolution stands for the ability of a digital sensor to distinguish between the grayscale value. Okay, and radiometric resolution, all in the case of panchromatic image, very clearly identify the grayscale. It can ranges up to 12 bit of image. It's the imagery of a panchromatic image. Within the variation of grayscale, within the variation of 0 to 256, that is the bit system. It's a 8-bit system. We can identify the object within the variation of black and white. That's why it is called the grayscale. Okay, this is the spot image within the grayscale. Sometimes grayscale, in spite of black and white combination, it's sometimes very useful to identify very minute object of the Earth's surfaces. And this is a radiometric resolution. It's a 8-bit image, and this is 4-bit image. From 8-bit image, more bit, it can varies up to 12-bit, more bit image, we can identify the more precise information, more vivid information, more clear information. Within the same spectral band, within the same band, there is a variation of intensity of wavelength, variation of the intensity of EMR radiation. That's identify the beat system, that is the radiometric resolution.